Alright, hello everybody, and today we're going to be having a look at the integral as well as the reverse power rule. So this is kind of like a follow-up video from the anti-differentiation video. So today we're going to kind of wrap up that idea with the integral, because you might notice that in the previous video where I drew some diagrams, we had x squared, and when we differentiated we went down to 2x, and you might have noticed when we went back up, when we anti-differentiated, we didn't really have some kind of operator, just like the derivative right here. So the operator for anti-differentiation is actually something called the integral, which comes from the name integral calculus, and it actually looks like this. It's a nice little curvy thing like so. So we know how to write the derivative. The derivative, we can write it as the derivative of x squared is equal to 2x, and to write the integral, all we do is we put that little long curvy thing on, and we write the integral of, let's say, this function 2x right here is equal to x squared. And notice I left a little space right here because there's actually something missing. We have to put down a dx. And this dx right here is quite important in the role it plays. I'm actually going to explain why this dx is important and why we need to write it down in the integral in the next video. But for now, let's just treat this as some kind of notation. When we want to anti-differentiate a function, we just slap it in between this integral operator as well as this dx. And of course, I kind of forgot it right here. When we anti-differentiate a function, whatever function we get at the end, we always have to put down a plus a c, because we don't know what constant might be there. So we've covered the integral, it's just some new notation. And now let's take a look at the reverse power rule. And as the name suggests, it's pretty much the power rule for differentiation, but reversed because now we're anti-differentiating. So we know the derivative of some function x to the n is going to give us n times x to the n minus 1. So what happens if we integrate or anti-differentiate x to the nth power? And remember the dx. So we kind of have to reverse this process somehow. So let's take a look at differentiation first. How did we go from the function to its derivative? Well, the first step was to multiply by n, okay? And then the second step was to reduce the power by 1, so n minus 1. And if we want to reverse something, well, we just reverse this process right here. So now for integration, our first step would actually be to add 1 instead of subtracting 1. And then our second step, instead of multiplying by n, we're going to be dividing by n. So let's actually try that out for ourselves. First of all, with this x to the n power right here, if we want to anti-differentiate that or integrate that, all we have to do is add 1 to its power, so x to the n plus 1. And then the second step is to divide by n. But notice, since these steps are reversed right here, we have to divide by the new power right here. So instead of dividing by n, we have to divide by n plus 1. And you'll see why that works out in a second. So the second step is to divide by n plus 1. And there's a little third step as well, which is just to add the constant. So plus c like so. So this is the little formula, the reverse power rule formula, in order to anti-differentiate a polynomial function, so x to the n power. And you can actually try and differentiate this thing, and indeed you still get x to the n. So if we want to differentiate x to the n plus 1 over n plus 1, okay, let's forget about the constant because it's going to be 0 anyways. So first of all, we're going to bring this power down. So we're going to have n plus 1 times x, and now we're going to reduce the power by 1. So we're going to have n plus 1 minus 1, and we still have this divided by n plus 1 right here. And notice this part and this part will cancel each other out. Plus 1 and minus 1 will cancel each other out, and we're going to be left with x to the n. So indeed, this rule does work. And using this rule, it's actually really easy to find antiderivatives now instead of using the process I outlined in the previous video. Because now if we want to anti-differentiate a polynomial function, let's say we wanted to integrate x squared and dx, all you have to do is use this rule. And the rule is really quite easy to remember because you look at this function and you see this power, and all you do is you add 1 to it, so we're going to have x cubed, and you divide by this new power right here. A lot of people might get this wrong because you might divide by the old power. It's always divide by the new power, so put down a plus c because we're done. Let's do another example. Let's integrate 5x to the 7th power dx. Okay, what exactly is that going to evaluate to? Well, let's actually forget about this 5 for now, so we're just going to leave it on the side. And let's take a look at x to the 7th power. Using the power rule, we're going to add 1 to the power, so x to the 7 plus 1, which is 8. And then we're going to divide by the new power. So we're going to have divided by 8, and we're going to put down a plus c. So this is 5/8 x to the 8th power. And let's do one more quick example. Let's get a fraction going. So maybe we'll do 2/3 x to the 1/3. Let's try to integrate that. Let's make things a bit spicy. So using the same rule, what we're going to do, let's leave this 2/3 on its own, and we're going to focus on this part right now. So we're going to have x, and we're going to add 1 to this power right here. So 1/3 plus 1, that's going to give us 4/3. Our new power is going to be 4/3 like so. And we have to divide all of this junk by the new power, which is 4/3. And whenever you divide a fraction, that's the same as multiplying by its reciprocal. So instead of dividing by 4/3, we can multiply by the reciprocal, which is 3/4, and we can clean things up a bit. This 3 and this 3 will cancel out, and this 2 and this 4, that's going to cancel out to a half. So we're going to get 1/2 x to the 4/3, and we're done. So we're going to put down a plus c, and this is the antiderivative of this original function right here. So that is pretty much it for this video. I just introduced this new notation of using the integral as anti-differentiating, and introducing the reverse power right here, which is just the reverse of the original power rule from differentiation. So yeah, if there's one thing to take away from this video, it's just this formula right here. It's really important, really helpful, and if you can memorize it and apply it, then that is very good. So hope you guys enjoyed this video, and I'll see everyone next time.